Hi YouTube, this is Joe Calton with Calton Cutlery. You can find us on the web, caltoncutlery.com. Today this video, I wasn't planning on doing it, so this one's entirely unplanned, but I figured since I just did the one on hand sanding a knife blade, and I talked about etching, and on one of the forums, Ed Fowler's forum, Knife Talk Online, we were just talking about etching blades in ferric chloride, and so I figured I just hand sanded one side of one blade, so we'd go ahead and shoot the video right quick. Anyway, so hand sanding, well, not hand sanding a knife blade, etching a knife blade. There's several different reasons to etch a knife blade. One of them is for just because that's the kind of finish you like. Another reason to etch blades, which I believe is a little bit more important than the final finish that you're after, is a double check of your heat treat. Okay, let's say we're doing, this one will show up real nice. Okay, most of my blades get edge quenched. Okay, so they are a differentially hardened blade. The reason that I like differentially hardening blades is because I get to run different portions of the blade at different hardnesses. Okay, so this is a 5-inch utility knife at a 16th inch 1095. Okay, now this one has been triple quenched in 130 to 140 degree canola oil. Alright, now you'll see the different colors in this blade right here. This is gray, a little bit of brown, and this is mostly black. Fresh out of the quench, this will be a solid gray. There'll be no brown. But then you wipe the blade off to get most of the oil off of it, and then when you stick it in your high-tech toaster tempering oven, the oil that's still on the blade will burn off and it'll turn this brown color. Now, there's several checks that you can make with this knife to make sure that what you wanted to have happen in heat treat actually happened. Your first check is going to be the appearance of it. Okay, we have this nice, even distinction in the blade, to where we can tell that this part right here, this light brown stuff, is the hardened portion, and the black stuff is the unhardened portion, as the simplest that it can get. Now 1095 also air hardens to a certain degree. Okay, so this black part, while it is unhardened, it just wasn't hardened in oil. It will still get some air hardening going on. So you can check with a file. This is a 8-inch Nicholson Black Diamond Mill Bastard file. So we can check it along the edge, and that sound you hear is pretty much, there'll be a layer of steel on the top that lost carbon because it was exposed to the heat from, in this case, the kiln. So usually you'll have a couple of strokes where the file will kind of bite and kind of not, and then as soon as you get past that first couple of strokes, you'll get that stating sound where the file's not cutting it. Now if you go to the spine, there's a completely different sound. There's no ring, and I can feel that file biting in there. Okay, so that right there is a check of your heat treat right there, just your scale patterns. And I have a video on reading your scale patterns, and that tells you an awful lot about your heat treat. Now, once you get to the point where you've ground this blade, and let's say this little necker right here. Okay, well you can't tell what happened in this part of the blade anymore because it's all shiny. You can tell from this portion, okay, this part's hard, this part's soft, alright, but you cannot tell if that blade was burned during heat treat. Okay, if you get too, I grind most of my blades, like this one right here, quenched it full thickness. There was no bevels ground into the blade before heat treat. The reason I do that is because the steel that surrounds the future cutting edge will protect the steel that's going to be the future cutting edge from the effects of the heat from the heat treating process. Okay, but there's a whole bunch of different stuff that can go wrong with that blade after a successful heat treat during cutting in your bevels, sharpening, and finishing out that you might not know about. If you get a little too heavy-handed on this blade while you're grinding it, whether you grind it dry or if you run your grinders wet with water as a coolant like I do, you can overheat that edge. The edge especially, because it'll get thinner and thinner and thinner. And of course my timer went off. So we'll come back to that right quick. What I've got here is a timer set up. The blade was in the ferric chloride. We've got ferric chloride there. Got this at Jant's Supply. And the mixture, I always write it on the top of the can. I mixed this at 9/17/15, so September 17th of this year. And it is 1 part ferric to 4 parts distilled water. Make sure you use distilled water. Some tap water has stuff in it that'll kind of mess with your etchant. So anyway, so here's the blade. I've got just a rod sitting through one of the tang holes to keep it at the right level inside the ferric. And you pull it out. See that nice line right there? That is the same line that you would have seen before I ground it of the scale patterns. So we use the acid to etch the blade, and when it etched, what it really did was the acid cut the hard part and the soft spot part differently, and that's where you get that variation going on there. So it's been in the acid for 7 minutes. We're going to go ahead and wash it off right quick. Just rinsed it off in hot water without touching it, and into can't remember what you call it, but this is TSP solution. You can get TSP at Home Depot. I think baking soda would probably work also. And it just neutralizes the acid. So we're going to leave it in there for 7 minutes while we go back to talking about the edge thing here. And then we'll go about some tips and tricks on etching and also what we're looking for. So anyway, so this blade right here, if while you were grinding it you got a color change on this steel, usually it'll happen near the edge where the edge will turn blue. Well, it can turn all kind of colors from, just a slight yellow all the way up through dark brown, blue, purple, and then go back to silver. Those are oxides that'll tell you the temperature that steel reached when it got overheated. Okay, well, it's real simple to take. If you're not a very scrupulous knife maker, let's say you turn part of that edge blue while you're grinding it. Well, what do you do then? Personally, if it turned blue, it's junk. We're going to toss that blade in the trash can. Or, even better yet, take that blade, clamp it up into a vise, bend it over, break it, use it as destructive testing, learn something out of that blade. But let's say you're not quite so honest. Well, all it takes is one more light pass on that belt grinder, and you just ground that surface oxide off, and nobody can tell that you overheated that blade until they go to start using it. And different portions of the blade will act differently in use because you will have a whole bunch of different things going on in there. You might have overheated the tip and not the belly. Well, that tip is going to dull at a faster rate than what the belly will, because the tip has been overheated and the belly was still okay possibly. Etching a blade can show you that, and we'll get to see that here in a second. This blade, we'll get to see if I overheated the edge or not. That right there is the biggest thing that I like about etching a blade. It gives you a view into the heat treat and the history of that knife like no other process that I know about. You can't, well, you can fake an etch. Maybe one of these days I'll tell you how to do that, but not today. But an honest etch tells you so much about that knife that you would not normally know. It's amazing. So anyway, so prep work before you etch a blade. What we're doing now is we're etching that blade that I hand sanded to 400 grit in the hand sanding video. But you take your blade, let's say whichever one, take your blade, and I hand sand them down to 400, 600, sometimes I might go an 800 grit finish. It seems to me like the 1:4 mix of ferric is about a 600 grit etch. So what I mean by that is if you have 600 grit lines running on your blade, that etch will eat those 600 grit lines away. If you go to an 800 grit finish, you might get a little bit clearer picture, but it's not going to be very much. A 400 grit finish, you'll be able to see the sanding lines, and you'll also be able to see the hardening line and if the edge was overheated also. Now, when I hand sand that blade, the last thing that touches that blade before it goes into the ferric is the sandpaper. You don't wipe it on your sleeve, you don't clean it up with a rag, you don't nothing. That 400 grit sandpaper or whatever grit sandpaper will leave a mechanically clean surface for the etch to work on. Now, like my friend Ed, he buffs a blade out to a mirror finish and then cleans it off with acetone or carbon choke cleaner, electrical contact, you know, the spray type cleaner, and he gets pretty good results that way. Me, I like a mechanically clean surface that has no buffing compounds or polishing compounds or anything like that to go into the etch. In fact, even something as simple as blowing on that knife blade, you know, you finish sanding it and you go to blow any dust that might be on there off. Drove me nuts one time. I was doing that and all of a sudden my blades, they kept getting all these spots on the blade out of the etch. And I'm looking at those spots and thinking, well, heck, did I overheat the blade when it went into right before it went into the quench? Did I get a bad lot of steel? You know, I had all these little spots that I didn't know what they were. And one day I was looking at them and I thought, you know, sure enough, it was moisture from my breath. When I blew on that steel to get rid of the dust, the little drops of spit that went through the air from my mouth were little spots where the etchant couldn't cut that steel the same as it could the steel around it, and it gave me those spots. The etch will show you a whole bunch of stuff like that. But anyway, so you hand sand it down to whatever grit it is you're going to go to. Don't touch the blade or do anything else besides that. Straight into the etchant with the little piece of wire supporting it up. If you don't want to use ferric, you can use vinegar. I've got a tank over here just built out of 4-inch Schedule 40 PVC that's filled with white vinegar. Works great for doing bigger knives like choppers and such. And then a timer. Make sure you get your process set and you do it the same way each time. So usually when I'm etching a batch of blades, I'll have one blade in the etchant, hit the button on that timer, and then I'll be hand sanding the next one. After 7 minutes, it comes out, it gets rinsed off, it gets put into this one, the TSP solution to neutralize the acid. The timer gets hit, and then usually the one that I just finished hand sanding goes into this one. The third jar is WD-40. And WD-40 does a pretty good job of setting the oxides on the blade from the etching. Okay, so now it's been in the TSP solution for 7 minutes, so this time we're just going to wash it off and then have a look and see what we see. Okay, so normally what I would do is just rinse it off in hot water and then put it in the WD-40 to kind of set the oxides. This blade, it's going to get hand sanded again anyways. I'm going to, because I usually etch my mark into the blade before I etch it into ferric. That's just my favorite finish to do. Anyway, so you can see on this one now, you can see that nice sharp hardening line right there. Grab one of the pencils from the sharpening video thing. See that line right there? Okay, so everything below that line is hard and everything above that line is either soft or it just got a little bit of air hardening, so it'll be much softer than what the edge portion is. Okay, now if there was, oh, that looks good. If there was any overheating done on any portion of the blade, especially near the edge, it would show up as like little, it would show up like as this color right here. Because it would be softer than the surrounding steel because it got tempered, because it got overheated. And you would see, you know, like maybe a little half circle right here. Oh, there we go. That one's got a... And this blade doesn't have any of them. Which if it did, I'd be really surprised. Usually the second I turn one blue, it gets chucked into the trash can. But anyway, you would see like a little spot like that. And you'd be surprised at how deep, like let's say you turn, oh, just this much of that edge blue. If it was a really thin blade, I wouldn't be surprised if a section just that size that turned blue, you would see in the etch a section like this that would show that it was damaged from that overheating. So if you're the type of person that likes to sharpen on power equipment, and hey, I do the same thing. I sharpen on power equipment, but you have to have a very, very light touch, and usually just get it close. Okay, so like if I wanted to go ahead and sharpen this blade on the grinder, instead of taking it all the way to an edge by hand on the stones, I would do a 120 grit belt, and then I would have, let's take you over the grinder right quick. Like I said, this was an unplanned video. Okay, so here's the grinder. The belt direction usually comes this way. Okay, now this is a 220 grit belt, but I would drop all the way down to a 120 grit belt. And with a very, very light touch, come in here and, you know, start shaping your edge bevels. Okay, and then, you know, dunk the blade in water and, you know, to keep it nice and cool. But a very nice light touch with the grit going away from the edge with a fairly coarse belt to do your shaping, and then finish your sharpening on the stones. Because if you stay in one spot too long, or if you bear down real hard or something, and you get just the slightest bit of blue on that edge, that knife's junk. Or if you want to save it, you will have to come back in and cut however much of that blade that turned blue plus a little bit to get rid of that damaged portion, because it will run fairly deep in the blade, and you can see that from the etch. Maybe one of these days when I'm feeling too ham-handed and I do that to one, I'll make a video on that just to show you how deep it will run. But anyway, that's just a quick and dirty 400 grit hand sanded blade, dipped in ferric for 7 minutes at a 4 to 1, 1 to 4, 1 parts ferric to 4 parts distilled water, neutralized in TSP solution, and rinsed off right quick. They look an awful lot nicer when you shine them up, but this is the basics, and not only the basics of how you do an etch, but also the basics of what it is that you're looking for when you etch a blade. Now, when you get used to looking for that hardening line on a differentially hardened blade, you can see them sometimes from across the room. Like this one right here, I can see it plain as day in person. Ah, there we go. See that? Right below the glint. You can see a continuation of that quench or that scale pattern right there. See it? When you get used to looking for those, you can see them from across the room sometimes. Also, a lot of blades that the maker says were fully hardened, not with a differential heat treat. A lot of times, if you see little glints like that in the blade, even on a fully heat treated blade, you'll be able to see a hardening line in it sometimes. So anyway, keep an eye out for that. Once you get used to looking for them, you'll see them on an awful lot of knives, and sometimes they're not in the right spot they're supposed to be in, which is why I like the etch so well, because it's proof that it tells you what actually happened in the heat treat. Not what you thought happened, but what actually happened. And it's a crystal ball, really, to be able to look into the history of that knife as it was being made. And actually, it's really tough to hide too. When like I did a test with a friend of mine where we were comparing 6 different knives, one that I had heat treated and the other 5 somebody else had heat treated. I had done a differential harden on that blade, and the other 5 blades were not differentially hardened. Man, I tried all sorts of stuff to be able to hide that line. Never could do it. I just had to send him off to him and hope that he wasn't paying attention, which, knowing him, he saw it. But anyways, that's enough babbling. That's etching a knife blade in ferric chloride and why. Hope you enjoyed the video, and we'll see you next time.